All right, so we have this theorem, which is the unique factorization of integers, or the fundamental theorem of arithmetic. You remember the fundamental theorem of calculus, I'm sure. So this says if I have any integer n that's bigger than 1, then there is a positive integer k, so that it can be broken up into k different prime numbers, and maybe some of those prime numbers have different exponents to them. So what this says is you can uniquely break up an integer, positive integers bigger than 1, into products of primes to different exponents. So let's kind of play with this. So 100, I know I'm just going to go slow, 25 times 4. So I can rewrite this as 5 squared times 2 squared. So these are my two prime numbers, and these are my two exponents, or my e values, right? So this would be p1, this would be p2, and there's my e1 and e2, right? This is unique. So 100 written as 5 squared times 2 squared is unique, and it's in the standard factored form. Okay, so we get to use this to mean something. So if I've got a and b integers, and I know that 15a equals 9b, okay, does 9 divide a? So what I need to do is just think of breaking up each side. So 15 would be 3 times 5, each with the exponent of 1, right? 9 we've broken up into 3 squared times b. Okay, so what do I know? I know that I've got a factor of 3 here, and I've got 2 factors of 3 here, right? So since there's 2 factors of 3 on this side, there must be one more factor of 3 inside of a, correct? Because I've got 1 here, so one more must be hiding inside of a. So does 9 divide a? No. 3 divides a, but not 9 divides a, right? Because there's only a factor of 3 in here. Okay, so same question with this 15a equal 9b. Does 5 divide b? Okay. I have a factor of, let me just kind of play with this line here with red now. I have a factor of 5 on the left-hand side. I don't see a 5 on the right-hand side, so 5 must be in here. So yes, the factor of 5 must be in b, so that means 5 divides b. Okay, so let's start from run from the drawing board, and you can turn it off and try to do it on your own, or just kind of go along with me. So here's the statement, and then I've got 2 questions here. So let's break up 12. So that's 4 times 3, or 2 squared times 3 times a, equal 5 squared times b. Okay, so first off, does 12 divide b? So 12 divide b is the question. So let's look over here. So the number over here, I do have the number 12. I have the number, I have 5 squared on this side. So the number 12 must be over here somewhere, but the factors of 2 and 3 are not in 5 squared, so they must be in b. So the factors 2 squared and 3 must be in b, so that must mean that 12 divides b. Okay, how about 25? Does that divide a? So let's look over here. So I see that I've got 5 squared on this side. There's no 5s here, so does it have to be in here? It does. So does 25 divide a? The factors, the factor, I guess, of 5 squared must be in a, so that must mean 25 divides a. Okay, there's a little bit of a different question. So I've got this number here, so let's break it up so I can see what the factors are. So I know 45 is 9 times 5, so that's 3 squared times 5, all to the 8th power, right? Just going slow. And then this will give me 8 times 11, so that's 2 cubed times 11 to the 5th power. Okay, so let's break this up. So this will give me 3 to the 16th, 5 to the 8th, 2 to the 15th, 11 to the 5th. Okay, so I want to find out how many zeros. So that means I want to find out how many factors of 10 there are, right? How many factors of 10 can you see in here? So if I look at here, 3 to the 16th, I'll leave that over to the side. 11 to the 5th, I don't need that. Here. So if I have 5 to the 8th, and if I break this 2 to the 15th up to 2 to the 8th and 2 to the 7th, these two here make a factor of 10. So I will have 8 zeros, right? Because there'll be 8 factors of 10.